Mars Olympus Mons may have company in biggest volcanoes club in Earth vertical bracket Ars Technica. Ars Technica. Home. Main menu. Information Technology Lab. Product news and reviews gear and gadgets. Business of Technology Ministry of Innovation. Security and Activism Risk Assessment. Civilization and Discontents Law and Disorder. The Apple Ecosystem Infinite Loop. Gaming and Entertainment Opposable Thumbs. Science and Exploration The Scientific Method. Feature Series Keep your eyes in the enterprise fresh insights into the ever-evolving world of it. Site theme. Dark on light. Light on dark. Explore ours. Reviews. Video. Staff blogs. Feature archive. Staff directory. Contact us. Featured disciplines. Photography. Productivity. Cloud. Gadgets. Tablets. My stories 0. New, since last visit. See more news stories. We recommend. My discussions. Log in to track your discussions. Forums. Subscribe. Jobs. Log in. Search. Scientific method, science and exploration. Mars Olympus Mons may have company in biggest volcanoes club on Earth. Geophysicists studied an underwater body called the Tamu Massif. And it's massive. By Scott K. Johnson, September 6, 2013, 6:15 p.m. UTC. Earth Science. 51. In large, Tamu Massif, part of the Shatsky Rise in the western Pacific Ocean. William Sager, William Durkin IV. Olympus Mons, Mars' massive shield volcano that rises over 20 kilometers into the air and covers an area the size of Arizona, is one of the most impressive geological features in the solar system. It's difficult to imagine such a gargantuan volcano in the surface of the Earth. But maybe that's only because we haven't looked hard enough. The Shatsky Rise is a seafloor plateau in the Pacific, about 900 miles off the coast of Japan. In total, it's about the size of California, sticking with U.S. states as units of measure. Like other oceanic plateaus, it was built by huge outpourings of lava. They are thought to be similar to continental flood basalts like the Columbia River basalts and India's Deccan traps that are associated with mantle hotspots. Prodigious amounts of lava issued forth from long fissures and smaller vents during those events. There are still things we don't know about these kinds of eruptions, so you can imagine how much less we know about the plateaus at the bottom of the ocean. William Sager, a professor of geophysics at the University of Houston, is one of the researchers who has been studying the Shatsky Rise. The plateau is made of several separate chunks called massifs that formed about 145 million years ago, the largest of which is Tamu Massif. I have suspected for years that Tamu might be a single volcano, Sager told Ars. We have known the shape for many years, and it appears to be a big dome. But when I would make this assertion, other scientists would say that I should not be so quick to jump to that conclusion, because continental flood basalts have complex eruption sources, often along long fissures. They were right in the sense that the shape alone is not proof. The latest project, which involved researchers from 6 universities, sought to learn more about the inner structure of Tamu Massif. Sediment and rock cores collected over a few years gave a glimpse of the layers of basalt that stacked up to form Tamu, but that didn't indicate anything about where they erupted from. To investigate the source, they used seismic imaging to build cross-sections through the massif. This technique emits seismic energy using powerful airguns and records the echoes of those waves bouncing off layers at and below the surface. Those cross-sections didn't show a jumbled collection of vents glued together by lava flows. Instead, Tamu appears to be an orderly, layered stack of lavas that flowed hundreds of kilometers downhill from a central point. That would make Tamu a single, enormous volcano and easily the largest identified in Earth. In fact, its area is about equal to Olympus Mons. While it's only about 3 kilometers tall, it has greatly depressed the thin oceanic crust beneath it. Combine